Welcome to the 3D modeling video series. This tutorial demonstrates the sweep functionality in Build 3D, which can be used to generate three-dimensional geometries such as curving tunnels and levees adjacent to natural rivers. In GeoStudio, we will start in a project with a seepage analysis associated to a 3D geometry. Basic material properties and boundary conditions have already been created in the Define Materials and Boundary Conditions dialogues using the same method as in SeepW analyses. A two-dimensional cross-section has been imported from the 2D analysis in this file. For instructions on how to import a 2D analysis into Build 3D, please see the previous tutorial videos in this series. Let us now launch the 3D editor by going to Define, Launch Build 3D, or by clicking on the Edit with Build 3D icon in the top toolbar. In Build 3D, we see that the 2D cross-section has been extruded to generate 3D bodies. However, the extrusion functionality only creates solids along straight lines that are orthogonal to the extruded cross-section. In this case, we wish to investigate the corner section of a tailings dam. Thus, I want to sweep the two-dimensional cross-section along a non-linear pathway. To do so, we must first draw the pathway we wish to sweep the cross-section along. We can draw the pathway using the top construction plane. Click on the top plane and select the sketch icon. In the Sketch Editor window, let us select the Spline Drawing tool to generate a sketch with both curved and straight sections. Once finished, press OK to save the sketch. Right-click on Profile 1 in the design history and rename it Sweep Path. We will now sweep the cross-section along this path. Click on the 2D steady-state seepage sketch and select the sweep icon. When you do so, you see the 2D cross-section automatically appears in the Profile Input box. Now we will click the Path Input box and select our Sweep Path sketch. To generate closed solids when sweeping this cross-section, ensure the Close Caps option is selected and press OK. We see that the model domain extends around the defined corner, and the materials and boundary conditions have been applied accordingly. We would need to generate the finite element mesh before solving this analysis. In this analysis, we will start with a solid representing the overall domain we wish to model. We could import a CAD file with a river pathway. However, I will draw it for illustrative purposes. To do so, click on the top plane and select the sketch icon. I will use the Spline tool to draw a meandering river pathway and then press OK to save this sketch, which I will rename River Pathway. To move this sketch so it is on the top surface of the 3D solid, right-click on the sketch, select Edit Plane, unlink the sketch from the top plane, and input 30 meters in the offset box. Now we will sketch a river cross-section to sweep along this pathway. First, we must create a plane to sketch the river cross-section on. Select the plane icon and click at any point along the river pathway spline. This new plane appears in the design history. Right-click on the plane and select Sketch to open the sketch editor. I will now draw a river cross-section with the first point starting at the axis of this plane. To sweep the river cross-section along the river pathway, right-click on the sketch and select Sweep. In the Path Input, select the river pathway. We can add slices along the swept profile by editing the distance from front input and pressing Add. I will add slices at 40 and 80 meters. After pressing OK, you will notice that the swept object creates multiple solids based on the position of the defined sketch plane and slices. To create the river valley, we must remove these solids from the domain. I will select the solids I wish to remove and press the Cut icon. The solids are listed in the Bodies A input in the Cut editor. I will select the Cut and Remove tool such that these solids are completely removed from the model domain. After pressing OK, we see the swept river valley running through the original model domain. We could now create additional geometry features before applying boundary conditions, generating the finite element mesh, and solving the analysis. Thanks for watching and enjoy using Build 3D.